Okay, we are going to cover 3.1. So talking about quadratic functions. So this is something that you've covered for a while now in algebra 1 and algebra 2. So let's draw an x and a y axis. So x and y. And let's have the vertex of this quadratic be on 3, 1. So it's just moved over. And then do up 1 over 1, and then left 1 up 1 from there. And then it's 1, 1, 2, 4. And then from this point, go up 1 over 3, and then left 1 up 3. And we're going to draw the parabola. The parabola does not look very good, but there you go. So we're going to label some things on here. So one of them is right there. That is our vertex. And in this case is going to be our minimum. And then our axis of symmetry goes down the vertex. So this is called your axis of symmetry. And I'll usually abbreviate it with AOS, axis of symmetry. And our axis of symmetry is a vertical line, so it has an undefined slope. And the way you find it is x equals negative b over 2a. And then let's write out what the standard form. It is f of x equals a parentheses x minus h squared plus k. And the vertex is actually HK. So we would go over H, up K. That's where that is, over H. So in this case, our vertex for this example would be 3, 1. This is our vertex and our minimum. And then our axis of symmetry would be x equals, so it's negative b over 2a. Well, we don't know what b and a are because we don't have the general form. But we do know that it's at x equals 3 as the vertical line where x equals 3. So this is h, this is k. And then a is how wide and how narrow it is. So in this case, it's just 1. So if we were to write this function, it'd be f of x equals 1 parentheses x minus 3 squared plus 1. And then if you need to, you can simplify it. But if we have another function, I'm going to graph another function. I'm going to do it 1, 2, 3, 4, negative 4, 3. I'm going to do the same thing where it has the same width. There we go. I'm just not good at drawing these. Because I'm a perfectionist. There we go. So the thing that's different about this is our vertex, but now it's called a maximal. And then we still have the axis of symmetry. And then this one we have x-intercepts. This one had no x-intercepts. But this has your x-intercepts, which are also called zeros or solutions. And then whenever you actually graph this one, not graph it, but write the equation, your A is going to be a negative 1 because it's flipped over. Because the parabola is flipped, or it's flipped. This one was positive 1. Okay. And then domain and range for this. So your domain and range for parabolas, your domain is all real numbers. As long as it goes on and on. It's going to go from left to right. So negative infinity is less than x is less than infinity. But your range, if it goes up like this, then it'll be the vertex, which is the k, is less than or equal to y, is less than or equal to infinity. Because it starts here and it goes up to infinity. Or it can say that y is greater than or equal to k, whatever k is, which k is where that vertex is, the y value of the vertex. But if it is where a is negative 1, it's going to go the opposite way. It's going to go negative infinity is less than y is less than whatever k is, less than or equal to. And we'd write it as y is less than or equal to k. So it's either greater than or equal to the lowest point or less than or equal to the highest point. So this is whenever K is a minimum. Whenever you have a min, and this is when you have a max. So that's just a quick review over some of the attributes of quadratics. So let's look at the problems that are in the printable notes. All right, number 1 on the solve problem. The vertex of parabola is also called the turning point. That makes sense, right? It's where it turns, so that is true. And they already wrote that for us. The vertex of parabola is always called the minimum. True or false? False. Because if it's like this, it's minimum. But if it's like this, it's maximum. Okay, 2a, graph the function. So the way we are going to graph it is we are going to list out all the attributes of it, our axis of symmetry, our vertex, whether it's a min or a max. So in this one we have h and k, which it tells us hk is 1, 4. And then because this is negative, that tells us that we are going to have a maximum. So it's going to open downward. And then we'll plug in and then solve for our intercepts. So let's see. We have h and k for our vertex. It's going to be 4, negative 1. And then it's going to open upward because this is a positive. So this is a minimum. And then we want our axis of symmetry. What is this going to be? What did we say? X equals H. X equals 4. And then we need to solve it out to find our zeros. So f of x equals x minus 4 squared minus 1. To find our zeros, we'll plug in a 0 for y and solve for x. So we would add 1 to both sides. And then take the square root. And then add 4 to both sides. Oh, square root of 1 is 1, isn't it? So I should have just replaced it with 1. Well, it's positive 1 and negative 1. So that means we're going to have 2 solutions. So we're going to have 4 plus 1, which is 5, and 4 minus 1, which is 3. So these are the intercepts. Okay, so let's check this in the calculator. Let's review our calculator skills too at the same time that we're doing this. Do you need to borrow one of mine? I have them in the back. So let's go to y equals, let's plug it in. So x minus 4 squared minus 1. And then go to graph. Okay, our min should be at 4.1. Do y'all remember how to get your calculator to actually find that value for us? Does anybody remember that? How to calculate? Second calc. Or trace, yeah. And this is a min, minimum. So we're going to go to minimum. And then left bound, well, we need to find our little cursor. Here it is. We want to go on the left side of our minimum. So our minimum's right there. Go on the left side of it, push enter, and then go on the right side of our minimum. Push enter, guess, enter. It's 4, -1, so we did that right. And then we can find our axis of symmetry from there. And then our next step would be our zeros. So our calculator will do that too. Second, trace or calculate. We want to find a 0. So go to our first one. Go to the left side of where it intersects the x-axis. Push enter, then go to the right side of where it intersects. So we're wanting that point right there. So we're going to go to the right of it because it's asking right bound. Enter, guess, enter. It's at 3, 3, 0. And then you can do the other side too. We want a 0, left bound. So we're going to go to the left side where the parabola crosses the x-axis. Enter, right side, enter, guess, enter. So 5. So that's how you can find all those attributes using the calculator. So remember, I record this lesson. I'm putting it on Blackboard. So if at any point you're totally confused, you can go back and watch these videos. Okay, let's go to the next page. Okay, 2b, graph the quadratic function x squared plus 3x minus 10. Use the graph to identify the function. So we can graph this in our calculator, and then we need to find our vertex. On here, the first thing they did was they found a, and it's ax squared plus bx plus c. So our a tells us if it opens upward or downward. So this one is an upward, so it's going to go like that. And then to find the x coordinate of the vertex, it would be negative b over 2a. So that would be x equals negative 3 over 2 times a. So 2 times 1, which just equals negative 1/2. Or negative 3 over 2. We can write it either way. So this is for the x coordinate of the vertex. So to find the y coordinate, we would plug in the x value. So it'd be negative 3 over 2 squared plus 3 times negative 3 over 2 minus 10. And yes, I know we can do this all in our calculator, but you need to be able to show it on paper too. Negative 3 over 2 squared plus 3 times negative 3 over 2 minus 1. Oh, minus 10. I was like, that's not right. Thank you. There we go. So that ends up being negative 49 over 4. So this is getting the exact answer as a fraction. So this means that our vertex is at -3/2 and then -49/4. And then we need to find our zeros. So we need to solve this function. So the way you solve it is by factoring it and then solving and or setting it equal and solving. So what has a product of -10 and a sum of 3? Okay, so 5 and 2. Which one's negative? 2. Okay. So that means this is x plus 5, x minus 2. So we set it equal to 0 to find our zeros. So x plus 5 equals 0, and x minus 2 equals 0. Solve those out, and x equals -5, and x equals +2. So if you were to graph this, you would have -5, 1, 2, 3, 4, 5, and +2. Just a rough sketch. And then the vertex is -1.5. So our axis of symmetry is at -1.5. And then what's -49 divided by 4? Okay, -12.25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12.25 is like that, I guess. And so then you could kind of trace out a parabola. And we can also do this in the calculator, check our work, make sure we graphed it correctly. So in Pearson, you are going to have to pay attention to what these values are to know which one is the correct graph. All right, let's continue on. So number 3, consider the quadratic. Determine without graphing whether the function has a minimum or maximum. What tells us if it has a minimum or maximum? Yeah, the sign in front of the A. So what is it going to be? Yeah, because it's going to look like this, so it's a max. Find the min-max wherever it occurs. So to find our min or max, we got to find our vertex, and that's x equals -b/2a. So this is A, B, and C. So it's -8/2 times a -4. -8/-8, which equals +1. So our axis of symmetry is going to be where x equals 1. So that's part of the vertex. To find the other part, we need to plug in to the original equation a 1. And what does that come out to equal? Was it 1? So our vertex is at 1, 1. And domain has no restrictions because it's going to continue to go left and right in both directions. So it's all real numbers, or negative infinity is less than x is less than infinity. I'm going to put all real numbers too. So then since our maximum is at 1, 1, it's going like that. So the highest the y values can be is 1. So it's y is greater than or equal to 1, which was our k, remember? Thank you. Less than or equal to. Because it has to be lower. Good catch. We can also write it as negative infinity to 1. Okay, number 4. Among all pairs of numbers whose sum is 16, find a pair whose product is as large as possible. What is the maximum product? So having a sum of 16, we want the product to be as large as possible. So we want to maximize P of x times y. And the sum of these numbers, x plus y, is going to equal 16. So let's solve this equation for y. So it's going to be y equals negative x plus 16. And then we are going to replace, we're going to do some substitution. We're going to use x as x, but we're going to use y as this and input it for y right here. So we're doing some substitution. So it's going to be P equals x times a negative x plus 16. Negative x squared plus 16x. So we are going to write this as a function of negative x squared plus 16. And we are going to describe this and figure out the maximum point. Isn't the function going to look like this? And we want to know what that maximum point for x, y is. So this x, y should be, if you add them, you get 16. And if you multiply them, you get the largest possible value. So we need to find the the vertex. So we're going to do x equals negative b over 2a. So it'd be negative 16 over 2 times 1. Negative 1, yep, almost forgot that. So negative 16 divided by a negative 2. Positive 8. And then we do plug that in. So negative parentheses 8 squared plus 16 times 8 to figure out the y value. Well, shouldn't we already know what the y value is? What would the y value be? It would have to be 8 too, because they have to add up to equal 16. But does that work?
You can do that equation at the bottom.
Say that again?
Like the very bottom equation. The actually plug, like you figure that out, that's not 8.
No, that's not 8. So what's the problem?
Don't you just plug it into the next one, 5 and 6?
Wouldn't we plug it back into this one? Yeah. So we do 8 plus 8 equals 16. And 8 times 8 is 64. So that's the biggest number that it can be. So the numbers are x equals 8 and y equals 8. That's your max. Yeah, that was not going to work out. All right, that's it. So we'll do 3.2 tomorrow. I already put up 3.1. I'm going to give you my math lab day on Friday so you can get started on it, or you can do it now. It's up to you. Let's see.